Generic greetings and welcome to LogicBots, a puzzle game essentially. You will have to make a robot in order to complete a task or series of tasks, and you'll be placing the chassis, the wheels, all of the sensors, and then wiring it up and doing the logic, and it's quite an interesting and in-depth game, although because it's a puzzle game, after a while I end up getting far too confused and just sort of give up on it, which is why I haven't played this in quite some time, although as of late I've been in a very robot-y type mood, so playing Battletech and watching Robot Wars, so anything with robots in I've been sort of reinstalling and trying out again, and this is obviously no exception. I have featured this once before on the channel, although admittedly it was quite a while ago since that video was released, and how much have I remembered? Well, we'll see when we actually jump in and try that. By the way, today's beverage is peppermint tea. So let's go to Korea and see how far I got when I last played this. Not very far apparently, so I've got 7 out of 32 for college, and we've only got the first couple done. And what we're going to do is we're going to go for dashed line, which is the one before 1.5 platform, because I've never tried platform, but I think I remember doing dashed line. Let's have a quick look. So, oh yes, I think I remember doing this. So we'll have a quick look at our objectives. So build a LogicBot that can follow a dashed line. Your LogicBot must reach the finish line without crossing any of the hazard areas. So these are the hazard areas. I think we can look at the... Can we look at the map? I think there's a way to do that. There might be, but I can't remember how to do it. Either way, we have to go over there and do that. We've got, what else? We've got circuit board. Oh, view level, of course. That's it there. So that is our level. So we need to follow... Our robot starts here. Our bot starts there. And it'll follow this line, or at least it will try to follow this line and go around, and we have to reach this endpoint here. So we can see there's some nice gentle curves here, and then there's also some quite sharp ones around here, which is, well, we'll see how that one goes. We can't cross these lines, otherwise we fail it. Okay, fine. What else do we have to do? We've also got complete the level in 1:15 or less. Complete the level with a robot of 540 pounds. Oh yeah, generic units of currency. No, it's pounds in this case. Or less. And complete with 3 or less gates on it. Okay, fine. So it looks like I've done some records here, but let's just try and see how it goes. So, what we need to do, get a chassis. So main body, we've got 2 sets of chassis. I'm just going to go with the bot gear P6-S, and we will slam that down there. So we've got some sort of helmet on there, and we need to make it. We need to have it moving. So, oh, by the way, the arrows here do represent the direction of travel. So if you try to build a robot that will go that way, well, it is possible, but it means you're going to have to rewire bits of the robot when you do that. So we've got extension pieces, which is like angle bar, so you can like rotate it around. So like say 90. Can you type in here? You can type in there. Very clever. So you can sort of shove that in there, and you can put your sensors on the outside and stuff if you want to do that. You'll get more parts as you progress on through the game. So we'll go for wheels, and we've got a couple of type of wheels. We've got some medium pneumatic wheels, some caster wheels, and a caster ball. So we want probably 2 wheels on this, and we have to think about placement because it is simulated. If we put them at the back here and we turn it, obviously the front will swivel out more. So we probably want to put it quite centralized, and we could even have it very high up, so only a tiny bit of the robot is touching. So this is the connect wheel to motor, so we want the normal forward. Yeah, that's fine. And oh, good grief, that's on a little bit of an angle, but we should be alright. I wish there was a grid. Is there a grid available? I don't think there is. Axle offset. Does that? Yeah, so it does actually offset the motor there. So we can have a quick look around, and I reckon if we line that up so we can just see the flat bottom bit, one more there, we know that that is about right, and this is the right motor. Normal. Okay, so that should be okay. Then what we'll do is we'll place the caster balls on the bottom. What we'll do is I'll have it as 0 rotation, and then we'll have a caster ball on the back like so, and it's already, yeah, we're gonna have to redo the other wheels. Okay, that's not too much of a problem. And we'll put another one in there. So as you can see, they are too far down for these wheels, so we'll move the part and we'll move it to, I think, about there. No, a bit too low. Back up to there. As I said, if there was a grid, that would probably make it easier. Maybe there is a grid. Maybe I just haven't found it. As I said, very inexperienced when it comes to this game. So start that, and it is sitting on there. That's not too bad. Okay, so how do we make it move? Well, there's many ways of doing it. We do have sensors. We do have debugging tools as well, like little LEDs and such. And what I'm going to do I'm going to place some sensors. Currently, we've only got a line sensor, and what this does, it will detect a line and output a high signal. Again, this is off from memory. So if it goes on this black line, it will say, yep, I've detected that, no problem whatsoever, and it will output positive, otherwise negative. So what I'll do, I mean, in order to make it move, you could do many, many things. So you could have... If it was a solid black line, what you could do is have two sensors next to each other, and if either of those sensors detect, it will activate both motors. If one of them goes off, then it will deactivate that one, so it'll turn the other way, or something like that. In this case, because it's a dotted line, what we would have to do if we're going to do that method, we would have to have a sensor on the front and a sensor on the back, and if either of those detects a black line, it'll activate the motors. The problem with that is when we come to these corner pieces like there, because it'll come to a point where maybe the front or back does not detect it and it'll stop. So I'm going to go with a very, very, very hacky solution, and I'm going to place one on the left. That's actually the right, but left from where we're looking here. And one on the other side as well, and make sure they are about right. Yep, that is about right. Okay, so what I'll do is I'll just wire the motors to on and just drive the whole thing forward. And if we get to a point where we are crossing one of the lines, it will then turn it back the other way. So we'll go over to the circuit board and we will say bot gear the P6S1 and we'll shove that down, and what that does is gives us a 4x4 grid and also the outputs. So the current outputs are the motors and the inputs are our line sensors, which we will promptly put over on the left hand side. So our line sensors are what I'll have to do, I'll actually go back to construction mode and I'm going to click on this one and I'm going to say sense L and sense R. Alright, actually we should really do it properly, so it's it'll be sen underscore right, sen underscore left. There you go. Okay, so I mean the naming doesn't matter just as long as you know what it is, but I mean, you know, don't try to follow some sort of programming level, because otherwise you'll be naming the variables dog and cat and Dave and Phil and whatever, and you go back in and you look at your code and go, why have we got an and or connected to Jessica? I don't understand. I don't know what it was. Because you just want to get it done, and then you look back at your code later on. Yeah, commenting code. Not very good at it. Anyway, not very good at coding. Not very good at a lot. Anyway, so we got two sensors. We got these on and offs. What have we got? Well, we've got logic gates and we've got functional gates. The logic gates, we've currently got ands, ors, or nots. So the and gate is a case of if two are high, then it'll output high. The or gate is if either are high, it'll output high. So it means that if either of these detect, it'll activate. If the and one, it'll have to be both. Something like that. The not gate just inverts the thing. I believe so. Anyway, logic gate inverts the input. Yes, it does. It actually shows you on the right-hand side there. Shows you the cost and everything else. Cool. So, what else can we do? Well, I think it's quite simple, actually. We can go to this functional gates. We've got a signal splitter, which takes one output and outputs two. And we've got a dual switch, which is just activating, well, on or off. And I'm just going to slam that switch down there. They both are on by default. And I will say wire color red, motor on, and that should do us for now. What I'm going to do is click start and see if it does. Oh, it is actually going forward. So if we click start, it will drive forward, and it will not do much. It is bouncing around because it's a simulation, and quite frankly, these wheels are not circular. They might look that way, but I don't think they are, because obviously, well, it's a polygon. So yeah, it's bouncing around all over the place, and level failed because we smacked into this. But we know that it drives forward, so we've got that going for us. But we need to wire up the sensors. So what I'm going to do, go to circuit board, and we'll say the sensor output right. If the right side detects any, if the right side detects any black line, so it's drifting over to the left, we want to reverse the right-hand motor, because then that'll twist the robot round. Because the way we've placed it, it should spin on the center axis rather than the front or back. If I place the wheels at the back, then the front would be massively waving left and right, and we would get a slow robot because of that. So we're going to go for a different wire color. So we'll say sense right. We'll go on to the right motor, left motor, right motor, clicky, 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 clicky. Okay, let's see if this functions. Start. Yep, it's currently working. So I haven't got any debug tools, but it seems to go down there. What I'll do is I'll put some debug stuff on it, and we can see a bit better on how this is functioning. So we'll say we'll have an LED light, one there, and one there. Okay, go back into the circuit board, put some LEDs on there. Hang on, LEDs on. I have to put them there technically, I guess. There, and I'll wire that up to that, and it's a pass through to there. I think this is how it works. I didn't even remember. I forgot to rename the lights. So LED left, LED right. Oh yeah. So LED right goes to right. Okay, that works. So start. So you can see now that is lighting up when it gets a high signal. So when it detects. There you go. That's working so far. It's not going to win any speed awards, and it might not even complete this. I'm just assuming that it's about right. So far, it's functioning, and I'll take functioning over super efficiency anytime. I'm happy just completing the level, never mind making it the best that you can have. It's not going to win any speed awards, that's for sure, but it's certainly going to win an award for cheapness, because we've only used 2 sensors. We have used 2 casters though, so that might be a mark against us there. But the robot is driving, no problem whatsoever. That's good. We can speed it up. Oh, that's actually slow down. Whoa, yes. Like Max Payne. Without the bullets and the painkillers and the noir. So not much like Max Payne at all, actually. Anyway. So, let's see if we go... This is going to be the test. Can we get through this bit? Because that's quite... Oh. Oh, yeah, broke. See, it broke. It came off the track and went straight forward. Don't know why it did that. I'm going to max it out, and we're going to set it forward again. And we'll look at it in slow motion. Because I need to know why it came off the track. Now, it is possible for it to not do that on the second run, and that's because it is a simulation, and, things can happen. Where, actually it bounces around a little bit different to the other time. There you go, that's okay. Ah, look at that, it just misses it. It just misses that sensor. So what we probably need to do, it might be an easy task, it might not be, we'll see. What we'll do is we'll just take that, we'll move the part, and we'll move it, say, a block in to there. I've actually moved it down as well, but that's not too much of a problem, I don't think. Now this'll slow the robot down massively. There you go, it's actually detecting both ends, so it's just gonna wobble and wobble and wobble. And it also might not work properly because it will get on the corners, and yeah, we'll have to see what happens here. It's slower, but currently it's following the track in a more accurate manner. Because the sensors are closer together, it is detecting it more. Now can you see, this is why it is a, every bit of placement matters. Every nut and bolt, every little change can affect the robot in a dramatic way. In fact, this change, just by moving these sensors in by, say, an inch or whatever their own dimensions are, could be a pass or fail for us. So we'll speed up to max speed with appropriate music. So this is where we got stuck last time. So let's see what happens. Yeah. Yeah. Okay. Looks like that did the trick. Excellent. Yeah, that's all it was. That's all it took. No speed bonus or anything, because we need to complete it in 1:15, but parts use 9, gates use 1, cost 4.30. Job done. There you go. Okay, main menu. Let's go for platform then. So, never tried this one, and let's check out. It's a raised platform. This is a new one on me. Okay, so objectives. Build a LogicBot that can navigate its way along the raised platform without falling off the edge. Alright. Complete the level in 24 seconds or less. Complete the level with a robot cost of 450 or less. And complete the level without using any static value gates on your circuit board. Alright. Key parts. The laser ranger can be used in this level to find the edge of the platform and use this information to make adjustments to the LogicBot's path. Okay, view level. So, this is where we start, and it's going to go along here. Alright, so actually, quite honestly, it shouldn't be that difficult. And let's see how much I regret that comment in about 5 minutes' time. Yeah, if it's a laser rangefinder, all we do is we put it on struts going on the outside like antennas. And if it ever detects, say, over a couple of inches, so it, detects down here, these corners, then we just say, okay, turn the other way. Alright, so, what have we got? We have a SpiderTech DX1, which looks like a really dodgy computer case. Alright, so that is our robot. Wheels, we've got the standard wheels, so medium pneumatic wheels, caster balls. Can we put 4 of these on? Nope, we can't put any of them on, to be quite honest with you. What if it was an axle offset? Yeah, we'll have to use axle offset. Okay, so we'll have a 5mm axle offset, which will go on 1. Hang on. Ah, there you go. Look, see that? That's where it's starting to curve around, so we need to make sure it's close to the right as possible. 1. That's left motor normal. Can you hold shift? I really hope you can hold shift. 2. Don't know. Did that work? 3. Yeah, holding shift. Okay. And 4. Okay, so it's going to be a lot faster, probably. It's also going to be more expensive, and it's quite frankly not as good because it's going to require more wiring. But, let's not worry about that. So extensions, we've got a circuit board extension 3x3. Oh, okay. Right, so that'll increase the circuit board on our robot, because at the moment, that's our circuit board. And it's based on the robot we have. So that's fine, that's good. We've also got math gates. So we've got add gates and subtract gates. Outputs a sum of 2 inputs, and it does have an input type number. Now, can you see on the right-hand side it says number? Whereas these are booleans. These are basically on or off, yes, no. That's all it is. But these have got numbers in it. We've got greater than, less than. Okay. And now we've got monitor numbers and everything. And clamp rounds an input number to the nearest whole number. Yeah, okay. So we're starting to get some more coding. This is why I like the thing I like about the game is that it has the building and the coding at the same time. Like it mixes them quite well. So anyway, we've got these 2 things here. We got the 2 left and right motors, which these are connected to. I assume this is going to work. Let's just click start, and yeah, it just sits on there. That's okay. I was checking the dimensions, you see. So what I need to do is have it so we have a range sensor stuck out and ahead of these wheels, quite far actually. So extensions box section, we will have it as a rotation of 90 degrees. That's a 60 degrees. That's quite off 90, and quite frankly that's not worked out anywhere because that's not how I wanted it, because I wanted it on the end. Although I can I change the width? Yeah, you can change a big block of it. We don't need it, we only need it that. What else have we got? It's a box section. Oh, anchor points. Bar end. Add a new anchor point. There. That says end. I would have thought that would be in the bar end anywhere. Far end. Confirm. There's the anchor points. Okay. I've just got an achievement for doing that. I thought something like that would be in the. I thought it would be in the game. You would assume it would be. Okay, so we'll have it say 250mm. That should do us. And yep, that's about right. Okay, sensors, ranger lane. Hang on. Laser rangefinder. That's the words. I was using the right words, just not necessarily in the right order. And that points forward. That is no good to us. We will delete that part. Start again. So we'll say new anchor point. And we want it on there. So anchor point. We'll just say bottom. And Eddie and Richie will turn up and go, ah, anchor point. That's a weird reference. Okay. There we go. Shame we don't have emergency bitter. Okay, so there's our sensors. So this is in mils, isn't it? Circuit board. There's our outputs. I can't. The lazies. The lasery things. Okay, so this one, we're going to have it laser rangefinder, LRF, left. Laser rangefinder. Don't know why I'm having trouble with that. Right. There we go. So, I'm going to just move that one down because for some reason... Can we move it? Move part. Yeah, just cancel it for now. Move the part, move it down to there, put that in there. So the left. This will output, I'm guessing, it outputs, it doesn't tell me. Yes, it does. Measures distance of any object directly in front of the sensor and outputs a distance in meters. Oh, hang on then. Range 50 meters though. Outputs it in meters, does it? Okay. Might have to do that. That might change the maths we're going to have to do. Either way, what we'll have is we'll have functional gates number monitor there, static value there, comparison gates. If greater than, we'll have 2 of those. So, well, what does that output though? Input is number, output Boolean. That's what we want. Okay, so we want to have a constant value, so dual switch on, and then that's a simple matter of saying both motors on, left and right. Let me start that. It does drive forward and actually quite fast, and then oh dear, and broken. Yeah, but it does drive forward, which is good. So now what we want is, I'm hoping that if I wire this up, it'll tell me what the current distance to the ground is. It does. It does. That is excellent. So apparently I've placed that slightly, a little bit wrong. Now the question is, right, so we know that that to there is just over a meter. And in comparison with that, how tall is it? Well, nowhere near. So that's probably going to be 500 mil. Not that it matters too much. So, this, if it's touching the ground, it'll probably be, we'll say 250. We'll say 200. Actually, how has it done it? Is it that? 1.911 or 991. That doesn't look right. 200. Okay. What I'll do, I'll wire with blue our left output, left, if that is greater than that, which is not. So I'm going to have to say, like, delete that. 0.200. Which should be the case, yes. Then you want to reverse the left motors. This one, same deal. Delete those. I think that's a bit too... I don't know if that's right. It'll require some tweaking. Never used these before. Okay, so what we've done, at least what I've attempted to do, is have the left outputs, the left and right sensors rather, the rangefinder. They are displaying their range, which is currently 1.1 meters, I believe. That's what that is. And what we've done is we set 200 mils on a constant variable. And that is compared with these compares to say if the rangefinder value is greater than 200 mil, then you want to reverse the motor because it means that that edge has gone off. Whoa! Okay. Just wire that up there and wire that up there and start again. Much better. I wired the wrong ones up and it's going. It's going. This is the test though. Oh, it works. Right, 90-degree bend though. Oh, easy. Easy. Oh, GG easy. Time 22.31. Completed the time trial. It was 24 seconds. Parts used 9. Gates used 5. Cost 640. Let's go back to the objectives. So complete level with a robot of 450 or less. Well, we could do that. All we need to do is remove 2 wheels. That's pretty much it, I think. We can also, without using any static value gates on your circuit board. How would we do it with a static value? Remember, you don't have to do all of these in one go. It's just, you know, do it at your own leisure. So that first one, sorry, the second one here, complete level with 0 out of 450 or less. I think that's doable. Well, it's obviously doable, but I think I've worked out how to do it. Remove a couple of the wheels. That shouldn't be too bad. The one without using any static value gates, well, what have I got for static value gates? I've got a static value and a dual switch. Dual switch, not class static, but yeah, I thought either all these statics, but not, they're just functional gates. So in order to do that, what you'd have to do is you could have 3 sensors. One sensor would be right at the center of the robot. You would have it there. That would determine what the distance to the ground would be. And then you would compare that with that. And if that ever goes higher than that default value there, or whatever is in the center, because if that's about to fall off the edge, it's too late anyway, so it's not going to matter. So you have that right in the center. If that ever detects that it's over, then you would turn it the other way. So that's possible as well. Either way, that has been a little bit of LogicBots. It's still as good as when I played it, however long ago it was, and I'm going to be playing some more of this. Because I'm really into robots, and I think I've got my eye in now for some of this stuff. Hope you have enjoyed the video. Links in the description so you can check the game out yourself if you have any desire to make a robot and do some coding stuff. Well, not coding, but wiring up and stuff and all the basics. Then this might be for you. It seems to be quite an expansive game. And if you go back to, say, the main campaign menu, you've got, well, this is just, I've got another couple to do, and then you've got all of these other ones there, and I think there's also custom levels, there's different sandbox stuff, and Steam Workshop support, and yeah. It's, I think you're probably going to get you're probably going to get something out of it if you like the idea of that. Either way, links in the description, you take it out yourself. Thanks very much for watching, take care, and generic partings.